Hello everyone. Today I'll be demonstrating my SIEM platform project. The goal of this project was to build an end-to-end security monitoring platform that simulates how Security Operations Center analyzes and investigates security events. The platform generates realistic enterprise logs, detects suspicious activities using rule-based detections and machine learning anomaly detection, stores events in PostgreSQL, displays them through a live Streamlit dashboard, and integrates with Splunk for security investigation. And here we can see the README, which explains the background of it, how exactly like I implemented this, like the implementation of like using Docker and then running the live simulator and Splunk and then deploying to the live web page and then other stuff as well, which you look into yourself. So for this demonstration, I have two PowerShell terminals. So the first one is responsible for generating security telemetry. I configured it to connect to my hosted PostgreSQL database on Neon, which is the same database used by my developed Streamlit application. And the second terminal is responsible for forwarding security data into Splunk. I configured it with the Splunk HTTP event collector endpoint and authentication token, so it can securely send generated events into my Splunk interface. And I've already configured these environment variables before starting this video, so my credentials do not get exposed. So before running this, I'll show currently my live web page, which you can access by just clicking on this link right here. And this is like from data that I've already been running with, and you can see you can filter out by the severity, you can choose the rules, and then it shows like the log sources, detection engine, and stuff that you use for this project. And within this, you can see the alerts over time. With this diagram, you can hover over and see the date and the time, the alerts. And then you can see this already broke down the medium critical based off like what I filtered off. And you can see that top attacking IP addresses, alerts by detection rule, use of behavior analytics, and then with a heat map, and then detection, and then you can also see flagged logins, and then you'll see security alerts. And again, and all for this data, it is simulated data that is not real, which is like supposed to real like simulate real data. So now I'm going to be able to start the simulator. So within this, I'm going to go into my simulator and I'm going to run this Python script, which basically runs the Python file that is included in my GitHub repo. And within this, I'm going to keep it running. And this is basically simulating events. And I can stop it whenever pressing Control C. So I can see just waiting over time. This might take a little bit, but I'm going to wait so I can actually see events. And then after I Control C out of this command, then you will be able to see on this live web page, it will be uploading the events and showing it. And with these, in addition to normal activity, it periodically injects security scenarios such as failed login attempts, impossible travel, off-hours authentication, and suspicious IP activity. And this is basically generating real enterprise activity with Windows authentication logs, Linux SSH activity, firewall, and web server traffic. So as you can see, total events version 12, so I'm going to stop it. And you can see stop after 6 ticks, 12 events written. So then we can see before I reload the page, it has 260 events, 58. If we refresh the data, you have 272. You can also refresh with the web page itself. So we can see through running the script, it actually added the things, and then you can see it and like add to the different filters. So now we're gonna also go to my second one, which is sending this data to Splunk. So I have this command right here, the Python scripts send to Splunk Python, which runs a Python file with all. And with this, it will take all the events that we sent over and will forward it to Splunk with alerts, the events, the alerts, and then the total records forwarded. So as you can see, 573, 476, and then 79 total records forwarded. And this is basically the collected telemetry into Splunk using the HTTP event collector. And this allows the same security for my SIEM platform to be investigated using Splunk dashboards and SPL queries. So now we can go into Splunk, my local account, and then you could go into reporting, and then you can see something like this. You can choose the last 7 days. You can filter and you can see the different data for each of the different time logs and the different like IPs. You can see the risk score. IDs, descriptions, and all sorts of things that you can see. And then also, we have the platform right here that I created, which displays the total alerts, critical alerts, distinct attacking IPs, average risk score, and then detection rule, and all these other data that you can see and hover over. And again, with running the command for this, the send all, it basically updates the platform, and you can also like kind of like somewhere like before, you can filter it by last 30 days, 7 days, 24 hours, 4 hours, 15 minutes, whatever. And then you can also export it and save these so you can look back into it and see the data that you want to save, which is pretty cool. So again, um, so now going back into my GitHub repo, we have under the SIEM, the Splunk, and the searches SPL, I have these different ones that I created, which like this first one is brute force login attempts by force IP in the last 24 hours. So basically what you can do is copy this and then paste it into your search for the search and reporting. So then it'll filter out the data on which reports actually follow these things. So then you can view the events, you can click on the time. Okay, so this one doesn't work. So we can go back and source IP, we can view the events. And then here we go. You can see the different ones. And again, you can do save as, and you can do a report, you can alert to basically look back and send it to your clients or for future proofing for like your IT department to see, okay, these are some issues, these are potential like hackers, and you can use that to analyze the data. And then we also, again, we have other ones that I have implemented. I'm just like shown the top 10 attacks, IPs across all sources, off hour logins, basically from 6 o'clock to 22 Army time. You also have alerts by serving over time, such as IP matches against threat intel, bundle feed, etc., etc. And that you can play around with this and basically see that from your simulation. So basically, this is just like simulating. Okay, we're gonna have these different live log simulators that's basically producing alerts and these different types of alerts that you can also see here. You can filter it out, but also within Splunk, you can use it to basically make reports. And you can see that like the data is updated and it's live and it transfers over from the data that you can see from previously. So it's been a while since I report, but you can basically see all the different datas you can see that like report. So you can see like, oh, it like reported at this time, that's when I ran at this time, etc., etc. So it basically loads all the data, and you can always update it and filter it however you want, which is really cool. So in conclusion, this project demonstrates an end-to-end SIEM workflow including security log generation, event processing, rule-based detections, machine learning, anomaly detection, database storage, real-time visualization, and threat hunting using Splunk. And building this project helped me gain hands-on experience with technologies and workflows used in modern security operation environments. And you can view the website. I use SSH, deploying with firewalls, web server events, using Splunk. I use Neon to make the live web page, but also Streamlit, and then also using Splunk to show the analyst portion of it as well. And that's it. Thank you for watching.